My name is Leland Richardson. I'm a software engineer at Airbnb where I work on native infrastructure. And today I'm going to talk about a problem we have at Airbnb. This isn't a problem unique to Airbnb. Actually, many wouldn't even consider it a problem, but instead just the way things are and always have been. And the problem I'm talking about is that at Airbnb we write Airbnb 3 times. Every feature we add to Airbnb needs to get created for at least 3 different platforms: web, Android, and iOS. For each of these platforms, we write hundreds of thousands or even millions of lines of code to build out the features that make up Airbnb. Although on each platform, the result of the code is largely the same, it's not actually the same code. Each platform has its own set of frameworks and languages that separate them. We have JavaScript and React on the web, Java on Android, and Swift on iOS. We write all of this functionality separately for each platform. Each feature is likely implemented by a different engineer, a specialist for that one platform. This means that each engineer implementing it must go through the same process of gaining context on the nuance of that actual feature. And this means that each implementation will likely have its own set of bugs and corner cases that were missed on the first pass. At Airbnb, we've recently started adopting React Native for the development of some of the features on our native apps. So the result is that for these features, we write the core functionality in the language of JavaScript and React, sharing almost all of the code between iOS and Android. So for these features, we effectively move from writing Airbnb 3 times to writing it 2 times. So at this stage, we see that we're in a fundamentally different situation than before. At the language and framework level, we actually have some similarities. It's now feasible for us to have the same engineer, skilled in JavaScript and React, write the feature for all 3 platforms. Once for web, and then once for React Native, targeting iOS and Android. The interesting thing about this is that for that individual engineer, this can actually be a more frustrating situation than before. Even though we're effectively writing it 2 times instead of 3, it might be the same engineer doing it. And now that engineer has to feel the pain and agony of almost identical code, since they're now writing it in both cases. So if you're in this situation, the engineer in you might take a step back and try to figure out how to share this code. If we can somehow figure out how to get React Web and React Native code to work together, we can get into this ideal world of writing Airbnb just once for the 3 major platforms that we want to support. So it turns out this is much easier said than done. React Web and React Native are not easily compatible. And I'll go into a bit more about why later in this talk. But I want to talk about a way that we can make React not just support these 3 platforms, but any platform. I mean, I don't know. What if we could write it once, run it anywhere? Okay, so there's a bit of a stigma around this concept. The idea of cross-platform UI is not new, and there are a number of fairly mature solutions out there that do this. But these attempts have often fallen short and have burned really any chance of receiving a good first impression. So much so that the React community itself, for years now, has actually actively said, no, we're not trying to do this. We're not trying to write once, run anywhere. And at this point, there might be some of you listening to me now, and they're feeling a bit like this. Cross-platform UI is a pipe dream. Why are we talking about it? That it always results in subpar experiences and non-idiomatic code. And there might be another section of you that are feeling a little bit like this. You've been waiting for someone to say exactly this, and you're ready to drink that Kool-Aid as soon as it's served to you. Honestly, regardless of which side of the spectrum you're on, I encourage you to give it some thought before jumping to any conclusions. There is no perfect solution. But today I'd like to explain to you the way I think about cross-platform React and how I believe React has a real shot to be different. First, I want you to consider the fact that for the most part, the code we wrote for these 3 platforms was separate not because they were separate concerns, but because we were forced to write multiple implementations by the technology that was available to us. Separate concerns should be separate. By using a single language and framework, we've made sharing code extremely easy, but now you can draw the boundaries wherever it makes sense, not where the technology forces you to. So consider for a moment a world where every platform had one paradigm for creating UI and one ecosystem of mature cross-platform libraries, components, frameworks, and best practices. And ultimately, the goal is for code to be portable. Portable between any platform. Code that needs to be optimized for a specific platform or things that require platform-specific implementations can be easily accounted for. We don't want to have to write one single code path for all platforms or develop for the least common denominator. We want to share code that is the same easily and not share code that needs to be different. So this sounds great, but how do we get there? Can we actually make a React ecosystem work this way? I think we can, but to understand how React fits into all this, let's take a look back in time at React's history. So React started getting used at Facebook and Instagram all the way back in 2011. In March 2013, it got open sourced to a lukewarm reception. React was so new and different that the benefits weren't understood at first. Over time, the React community grew and grew, and it's now become one of the most active tech communities that's ever existed. And then 2 years after the initial open sourcing of React, React Native was open source. This was a huge shift for the whole community. Until this moment, virtual DOM was essentially just a buzzword that people thought had something to do with performance. React Native woke people up to the fact that React decouples building a UI from the underlying platform. React Native took advantage of this and utilized a React paradigm for building UI on two new platforms, iOS and Android. This really opened people's eyes. What other platforms could we do this for? This ended up being exactly the catalyst that was needed to get React on other platforms. Later, we saw React Native Web get open sourced, which allowed for people to use React on the web with an API identical to React Native's. Following that was React Native for macOS, React Native for Windows, React Native for Ubuntu, and even React Native for VR. So we see that React is already being used to target as many as 8 different platforms. Is React already cross-platform? Sort of. React certainly can target a lot of platforms, but none of them are compatible with one another. To show you what I mean, let's take a look at this hypothetical React component. Right now, the only thing this component depends on is React. And React doesn't really assume any platform, so it's cross-platform. But let's assume now that you want to allow for multiple children or you want to do some sort of styling. If you were using this in a web-based environment, you'd maybe wrap the return value in a div, give it a class name. React makes adding and creating HTML elements extremely easy. But now, in this moment, we've lost all platform compatibility. Div and class name are web specific. In reality, we should be thinking of any HTML elements that we're using in React as an implicit dependency on React DOM. Easy to write HTML elements in React were like the gateway drugs of React. Without them, moving from the pre-React world to the post-React world would have been too big of a shift. The cost of that, however, is that most of the React ecosystem today is implicitly dependent on React DOM. So with that said, the situation with React Native and friends isn't actually any better. As soon as we want to do anything in this component, we end up having to take on an explicit dependency to React Native, even though there may be other libraries with almost identical interfaces. Without a proper dependency injection system, our code has to choose one of the two. So in a nutshell, cross-platform React needs to solve this dependency problem. We need to agree on what the fundamental components are and what they do. So let's give it a shot. Let's standardize on a minimal interface or set of APIs that allow us to construct meaningful UIs and make sense across all platforms. I like to call these primitives. So where do we start? What are React's primitives? It turns out React Native has already done a lot of the heavy lifting. React Native was built for both iOS and Android, and to do that, they built a couple of really good general purpose primitives that had to work well across the two platforms. And because of that, they can also work well on others. As we saw, many libraries and other platforms are popping up with React Native-like interfaces too, so this is maybe a good place to start. These are all of the APIs that React Native exports. There's 73 in total. That's a lot of APIs. Most of these APIs are somewhat specific to the mobile platform, and many apps don't need them at all. For ecosystems that aren't React Native, this is a huge API surface area to keep track of and take on as a dependency. One thing I noticed is when I built out Airbnb's component library for React Native is that I only ended up using a handful of these APIs to create virtually the entire library. In fact, I only really ended up using these 7. These modules are the basis for what I call the primitives. The fact that so much of our code base could be expressed by just a few of these APIs really interested me, and I wanted to understand if other people using React Native were yielding similar results. So I wrote a script that tracked all of the React Native imports in a given code base and had a number of people using React Native outside of Airbnb run it on their applications. Based on this data, it turns out that together these 7 APIs account for roughly 82% of all React Native usage in the wild. There are a number of other APIs that React Native exports that could actually just be built directly with these primitives. They can be thought of as just useful compositions of these primitives and not actual primitives in and of themselves. And then there are a handful of other APIs. APIs that I believe do actually need to be implemented from scratch for each platform, but shouldn't quite be considered primitives. Some of these are straightforward to implement and others would not be, but these are the modules for which I believe a platform-agnostic third-party library could be made. Now, if you add all of these APIs together, that accounts for roughly 96% of all React Native usage in the wild. So with this new knowledge, the most practical set of primitives that I could come up with based on this were these 7 APIs. View, text, image, style sheet, touchable, animated, and platform. I've created an NPM package called React Primitives, which can serve as a root dependency for which a cross-platform React ecosystem is built on. View, text, and image are the 3 core static UI components. Views, the core layout component used for basic styling and for grouping and laying out other components. Additionally, we have text for displaying text and image for images. Style sheets, the JavaScript API, to create style rules that the other primitives understand and use to style themselves. A critical requirement for UIs to work consistently is to have a consistent layout algorithm. So in a way, style sheet can be thought of as the public interface of the underlying layout algorithm, which in this case is Flexbox. Touchable is the only primitive enabling user interaction. It's a React component that defines a view that is pressable and optionally drives animated values representing its press state. This does not directly correspond to any of the touchable APIs that React Native provides, but all of the React Native touchable APIs can be implemented trivially from this. Animations are a crucial component for pleasant user experiences, and the animated API pioneered by the React Native team does a great job making animations declarative in order to integrate really well with React. And then finally, we have the platform API. Platform is arguably a utility more than it is a primitive. And it allows us to easily specify different logical branches based on whichever platform we're running on. So a common question about the choice of these primitives is, why do view and text make better options than the web equivalents div and span? The React web community is much larger than the React Native community, so why not start with div and span? The reason is that div and span are built for the web, and having other platforms implement their complete interface is pretty much equivalent to building an entire browser. Div and span have hundreds of attributes that are spec'd to allow for the entire CSS spec, as opposed to just a subset of it. If we choose to implement just a subset, there would be a lot of really subtle things that wouldn't work. View and text are more narrowly scoped and have props that make more sense with React's component model. So, assuming for a moment that we agree on the interface that was just laid out, who's going to actually implement these primitives for each platform? Where does that code actually live? So it turns out that most of these targets have already been made. As we saw when going over React's history, many platforms have implemented this interface or something really close to it. Many of them live in separate repos and have separate maintainers, and that's okay. This is essentially a dependency injection problem. React primitives is just the interface, the contract, not the implementation. React primitives comes with an injection API where you can configure it for whichever target implementation you want based on which environment it's running in. This is the added benefit of allowing emerging platforms to use code built for more popular platforms with no effort at all. There's now no need to convince maintainers of those projects that they should care about a certain platform. By default, React primitives will come with a set of default injections for several different targets, but one can easily override them with a different implementation for a new platform. So a pretty valid question at this point is whether or not these 7 primitives are actually the right primitives. For example, the animated API is a pretty heavyweight dependency to be included as a foundational primitive. It's needed currently to implement touchable in a generic way, but could potentially be avoided. Similarly, scroll view is a pretty foundational component that can't be built from just the other primitives, and it's highly used, so perhaps it should be considered. Text inputs are an important form of user interaction, and they can't be built from just the other primitives. So one problem with text input being a primitive is that the text input varies a lot by platform, and some platforms, like for instance VR, it might not even apply as a concept. And then finally we have gestures. Gestures are pretty interesting to think about. Robust gesture systems are needed to make things like touchable and scroll view and animated work well together, and might be worth considering as a real primitive concept. Unfortunately, gesture systems are also incredibly complicated, and they're implemented quite differently per platform. And on the web, a pretty important platform, no one has really built a good gesture system yet. For the most part though, all of these questions, they all follow a similar pattern. Sooner or later, you'll run into something that really ought to be implemented using an API not provided by the React primitives, but rather by a module for a certain platform. It's really important that we don't lose the ability to take advantage of these platform-specific APIs when we want to. In order to do this, we can leverage another brilliant idea from React Native, platform extensions. We can standardize on this concept of platform-based file extensions. It's a relatively simple concept, but extremely powerful. JavaScript has a module system. We create modules as files and import them elsewhere in our codebase using the import keyword. The idea of platform extensions is to extend this concept slightly to introduce platform-specific implementations at the module level with the introduction of specific file extensions. In this example, we have the fancy button module, presumably a React component. The original implementation works fine on all platforms, so we just use a .js file extension. But maybe we have a custom behavior or enhancement that we want to make on an iOS device only with some iOS-specific implementations. So we create a fancy button.ios.js with the enhanced implementation working on iOS only. But on all the other platforms, it'll have the same interface as before. So now, when we import or require fancy button from any other file, it will automatically pull the correct implementation depending on whichever environment we're in. Sometimes we might not be able to have this generic .js implementation that works on all platforms. So instead of having a .js, we have a separate implementation for each platform that we're wanting to support. This works well because we can isolate the platform-specific nature of our application into single modules and expose it as one common interface. In more visual terms, if we imagine that we have this dependency graph between all of the modules in our codebase, we might encounter a situation where we want to do something platform-specific in a single module. Or maybe it needs to be implemented differently for each platform. In that case, we split that one module by platform, and in each platform, our dependency graph deviates slightly, but remains consistent for the rest of the code base. So let's work through a common example of this, a checkbox component. Arguably, a checkbox or a binary switch is a pretty fundamental UI component, and so many might think it should also be a primitive. On the other hand, we can implement this just fine as a component built on top of the other primitives. So we go out and we create our React checkbox library. In our package.json, we depend on React and React primitives and set our entry file as index.js. We then create our cross-platform implementation of the checkbox using view, touchable, style sheet, and any other primitives that we need. But on some platforms, this might not be good enough. For instance, on web, we probably wouldn't want to implement a checkbox this way. Even though it might function properly, it won't be very accessible and isn't compatible with parent form elements. So instead, we create a checkbox.web.js with an implementation optimized specifically for the web. We still use React primitives for things like styling, but we might actually render a standard HTML checkbox input instead of a standard touchable. There would be a lot of additional things we'd have to do to create a real production quality checkbox component to handle all of the different cases. But the main point here is that you're able to handle any platform-specific concerns in this file. Then the last piece would be our main entry file, where we simply import the checkbox and export it as our library's main export. This ensures that the proper file gets resolved for each platform. There are huge ecosystems around React and React Native right now, but they're isolated from one another. Converging on a set of primitives could allow for these two communities to unite. By having an ecosystem of mature, cross-platform libraries and frameworks built on top of primitives, new and emerging platforms are able to immediately leverage them. This does not need to be limited to only things that can be built with the React primitives module, and can extend into far more interesting use cases by taking advantage of this platform extension technique. As an example, let's consider charting. Charting is a very complex problem, and building interactive data visualizations is complex no matter which platform you do it on. Luckily, a couple of standards have emerged. SVG, a web-based standard, has native iOS and Android support, and a React Native binding for it has been built with all of the SVG elements. Using platform extensions, we're able to expose a new library with the same compatible interface on web and native. There are also some charting libraries on the web that target SVG and React. For example, Victory is a popular charting library built by Formidable Labs on top of SVG in the web. Interestingly, Formidable has also released an almost identical native version of their library that's built on top of React Native SVG. Again, using platform extensions, we're able to expose a version of the library that depends on React Primitives SVG and is thus fully platform compatible across iOS, Android, and the web. Here's an example of a chart that we're using in our main app being displayed on Android, iOS, and the web. The code that we write to display this graph and render this page is the exact same code for all platforms. Taking this a bit further, by doing this for a handful of modules we depend on, we're able to run our entire React Native code base on the web without changing much code. We haven't put anything using this on the web in production yet, but we're currently exploring the practicality of such an approach. Oops, sorry. So, as I get closer to the end of this talk, I'd like to ask a simple question. What comes next? If we as a community start building things in a cross-platform and platform-portable way, what changes? Building things in this way obviously solves a couple of big problems and opens up some new possibilities, but it also creates new problems that we didn't have before. For instance, when you're working with multiple platforms, there's a lot more cognitive overhead. We need to be building tooling to address these new concerns. For example, editor plugins that show which platforms a given file is used on, or perhaps which platforms it's safe to use on. A bunch of new ESLint plugins could also be made to effectively warn people about mistakes they might be running into related to this. It's not just about new tooling, though. By decoupling ourselves from the underlying platform, there's a whole new set of possibilities that are created when the effort to target a new platform goes down by orders of magnitude. I really enjoy this quote from Guillermo Rauch. React is such a good idea that we will be spending the rest of the decade continuing to explore its implications and applications. Recently, this quote hit home for us at Airbnb when we realized that we could leverage Sketch, the application our designers use, as another target for our React code bases. We could actually use our production React code and component library in order to render directly into Sketch and make our designers' workflow more efficient. We recently released React Sketch App, which does exactly that. And we're now exploring interesting ways we can build design tools that leverage our actual production component implementations in order to make our designers and engineers more productive. So the video you are seeing here is of a Sketch plugin we've been working on internally at Airbnb. Here we're leveraging React components that were initially targeting just React Native and are now rendering a component picker and previewer inside a web view on the left-hand side using React primitives and React Native Web. Those components are then dragged and dropped into Sketch on the right-hand side using React primitives and React Sketch App. So in other words, we're using a single React codebase rendering to two separate platforms to create designs for a third, fourth, and fifth platforms that we know will be accurate because they're leveraging the exact same code. Without having our component code automatically targeting all platforms, doing something like this would be completely impractical. So in addition to designing interesting new design tools, by having more and more of our code be platform portable, we're able to more rapidly investigate newer platforms. For instance, VR. So obviously this is a bit of a silly example. You wouldn't actually want to create a VR experience like this, so please don't do that. But I think it actually shows the power of portable code. Although VR has a wildly different interaction model than web or native mobile, there's still a lot of potential for sharing smaller components and UI elements that are expected to be rendered as a two-dimensional surface in VR. Whatever the next platform may be, I'm willing to bet that someone will be using React to render UI in it. And wouldn't it be nice if when you start to work on that platform, all of your existing code was immediately compatible with it? So I wanted to give a special thanks to Nicholas Gallagher for his excellent work on React Native Web and for collaborating with me on React Primitives. I'd also like to thank John Gold for the great work that he's done on React Sketch App and for many long discussions around the primitives. The next time you're creating a JavaScript library that depends on React, consider what additional dependencies you're taking on, both implicit and explicit. Consider whether or not it would be compatible with all platforms if you depended on React primitives instead of React Native or React DOM. Consider whether or not a simple platform extension file would make it work on more platforms than you originally targeted. Together, we have the potential to create a true cross-platform ecosystem. Thank you.